Hello and welcome to Stellar Sleep Channel. Tonight, we are going to gently travel through the quiet and fascinating evolution of space telescopes, the instruments that slowly taught humanity how to truly see the universe. From the earliest glass lenses turned toward the sky, to orbiting observatories drifting far above Earth's atmosphere, we will follow the calm path of discovery that reshaped our understanding of the stars. If this peaceful journey through space helps you relax, unwind, or fall asleep more easily, your gentle support truly helps this channel continue creating these calm and meaningful journeys for you. Now, settle in. Let your breathing slow and allow your thoughts to drift upward. Let's begin. Long before machines ever reached the sky, before rockets, satellites, or distant probes, human beings studied the universe with nothing more than their eyes. The stars were steady lights scattered across darkness. The moon revealed soft shadows and pale surface markings. The planets wandered slowly among fixed stellar patterns, drawing quiet wonder and endless questions. For thousands of years, the sky remained distant and unreachable. It could be observed, named, and imagined, but not truly explored. That all began to change when glass lenses were shaped with care and curiosity, and the first telescopes were aimed upward from Earth's surface. Early telescopes were simple by modern standards. They were narrow tubes fitted with curved lenses that gathered light and enlarged distant objects just enough to reveal new detail. When these early instruments were first turned toward the moon, mountains and craters emerged where once there had only been a smooth glowing disk. When pointed at planets, tiny shapes appeared where wandering points of light once drifted. Saturn, through these early lenses, revealed strange shapes that confused observers as if the planet carried handles on either side. Over time, clearer optics revealed those shapes to be vast rings, transforming Saturn from a point of light into a world with structure and form. Jupiter revealed small moons spinning around it, proving that not everything in the universe revolved around Earth. These discoveries quietly reshaped how humanity understood its place in space. Yet, even the best telescopes of that age were limited by one powerful obstacle: Earth's atmosphere. Turbulence shimmers and blurs distant stars. Even on the highest mountain peaks, telescopes could only see so much, always looking upward through a restless ocean of moving air. For centuries, telescope builders slowly improved their designs. Glass became purer, mirrors grew larger, metal structures became steadier. Telescopes climbed higher onto mountaintops, where air was thinner and calmer. These great observatories watched galaxies slowly drift across the sky, mapped star clusters, measured the movements of distant worlds, and listened to faint radio whispers from space. Still, no matter how high they climbed, Earth's atmosphere remained in the way. And so, a quiet idea began to grow. What if a telescope could rise above the air itself? What if an eye could be placed directly into the vacuum of space, free from clouds, storms, turbulence, and distortion. What if a telescope could look outward without anything at all between it and the stars? That idea rested patiently for many years, waiting for human technology to mature. Then came the age of rocketry. As humanity learned to lift machines beyond the pull of gravity, small instruments followed. Early space missions carried simple detectors, crude by later comparison, yet powerful in what they proved that machines could survive in orbit, could look outward from above the atmosphere, and could send their discoveries back home. These first space-based observatories did not yet take majestic images. Instead, they measured invisible light, ultraviolet rays blocked by Earth's atmosphere, X-rays that never reach the ground, and gamma radiation that passes through space unseen. For the first time, humanity could listen to the universe in forms of light it had never directly observed before. The universe began to speak in new ways. Satellites detected violent flashes from distant black holes. They observed hot gas swirling around invisible cores of galaxies. They recorded the quiet glow left behind from the earliest moments after the universe was born. Each discovery whispered that space was far more active, far more dramatic, and far more mysterious than it had ever appeared from Earth's surface. As confidence grew, so did ambition. Engineers dreamed of a true optical telescope in orbit, one that could capture visible light without atmospheric blur, producing images sharper than anything ever seen from the ground. This idea required extraordinary precision, enormous funding, and decades of planning. It was not simply a telescope, it was a promise. Years passed in careful design, testing, and delay. Every mirror had to be polished to extraordinary accuracy. Every instrument had to survive launch vibrations, vacuum, radiation, and extreme temperature shifts. Every system had to function perfectly, far beyond the reach of easy repair. At last, the dream became real. A great space telescope was carried into orbit aboard a space shuttle and released gently into the blackness above Earth. It circled the planet silently, moving faster than sound, opening its eye to the universe without atmospheric interference for the first time in history. Yet even this triumph began with difficulty. A flaw in the primary mirror blurred its vision, turning crisp stars into softened halos. Disappointment spread across the world. But patience returned as engineers devised a solution. Servicing missions were sent. Astronauts worked in open space with delicate tools and steady hands, correcting the flaw and unlocking the true potential of the orbiting telescope. When the corrected images returned to Earth, they changed everything. Galaxies appeared in breathtaking clarity. Stellar nurseries glowed with dust and newborn light. Ancient star clusters shimmered like scattered diamonds. Humanity could now see farther and sharper than ever before. The era of modern space telescopes had truly begun. As you rest with this gentle unfolding of discovery, remember every advance came slowly, patiently, guided by quiet curiosity rather than urgency. The universe did not rush to reveal itself. It waited. And humanity learned, step by gradual step, how to look. Let that same patience now settle into your thoughts. Let the stars soften in your mind. Let curiosity become calm. As the first great orbiting telescope settled into its quiet path around Earth, a new kind of vision awakened. No longer softened by clouds or bent by restless air, starlight arrived clean and undisturbed. The universe, once blurred at its edges, now revealed fine detail written across unimaginable distances. With every passing orbit, this silent observer gathered ancient light. Photons that had traveled for millions and millions of years reached its mirror and were finally transformed into images that human eyes could understand. These images did not arrive loudly. They arrived gently, a faint glow here, a distant spiral there, but each one carried a message from a time far older than Earth. Scientists began to see that the universe was filled with galaxies too faint to detect before. They appeared in deep fields of darkness, where emptiness had once been assumed. Countless islands of stars floated through the black, layered one behind another, stretching back toward the earliest eras after the universe began. Space was no longer an empty stage with scattered points of light. It became a vast ocean of structure, depth, and motion. Space telescopes also revealed the quiet lives of stars. Within dense clouds of dust, hidden from Earth's ground-based instruments, newborn stars formed in warm pockets of gas. They ignited slowly, gathering mass, beginning long lifetimes of steady burning. In distant nebulae, massive stars reached the ends of their lives, shedding their outer layers into glowing shells that drifted outward like luminous echoes. Beyond visible light, other space telescopes opened entirely new windows. X-ray observatories revealed violent regions where matter spiraled into black holes and neutron stars. Radio instruments traced cold hydrogen drifting between galaxies. Infrared telescopes pierced through dark dust to reveal hidden structures where planets and stars quietly take shape. Each wavelength told a different version of the universe's story. Together, they formed a layered symphony of light, some notes soft and warm, others sharp and energetic, all flowing together in silent harmony. As confidence in space observatories grew, so did their diversity. Smaller telescopes were launched to study the sun in careful detail. They observed how magnetic fields twist and snap, releasing vast bursts of energy that ripple across space. Other observatories focused on distant galaxies, mapping how their shapes change over time, how clusters gather under gravity's slow pull, how the universe itself continues to expand. Some telescopes were designed not to take images at all, but to measure subtle movements, tiny shifts in starlight that reveal planets passing in front of distant suns. From these measurements, entire worlds were discovered, circling stars far beyond our own solar system. Some were massive and hot, others small and cool, A few moved through regions where liquid water might quietly exist. These discoveries did not arrive in sudden floods. They accumulated slowly, year by year, as data returned in patient streams. The universe was not forcing its secrets forward. It was allowing them to be found gently by those willing to look carefully and wait. As space telescopes multiplied, engineers learned how to place them in special regions of space where gravity balances allowed stable observation with minimal fuel. These quiet gravitational neighborhoods became resting places for observatories that drifted in gentle equilibrium, always facing outward into deep space, never needing to orbit Earth directly. From these distant vantage points, telescopes observed the faint afterglow left behind from the earliest beginnings of the universe itself, a soft background of microwave light that fills all of space. This ancient radiation carries the imprint of the cosmos when everything was young, dense, and hot. By studying its subtle patterns, scientists learned how matter first gathered into stars and galaxies across immense spans of time. The success of each space telescope quietly inspired the next. Designers refined mirrors, sensors grew more sensitive. Cooling systems allowed instruments to detect the faintest warmth drifting through space. With each generation, humanity's ability to see farther and more clearly expanded. Yet even as technology advanced, the guiding spirit behind space telescopes remained unchanged. These instruments were never built for speed. They were built for patience. They wait for light that has traveled across ages. They hold their gaze steady while the universe slowly moves through their field of view. In the silence of orbit, far above Earth's weather and noise, space telescopes became quiet witnesses to cosmic time. They did not chase spectacle. They listened, and the universe answered. Let this slow exchange settle gently into your thoughts. Light traveling for millions of years arrives without urgency. Discovery unfolds without haste. Understanding grows quietly, like dawn. As space telescopes continued their patient watch, the relationship between humanity and the universe changed in a gentle but lasting way. The sky was no longer only something to admire from below. It became a place we had learned to observe from within, quietly sharing its vast silence. New generations of telescopes were guided into space with ever more focused purposes. Some were sent to study the faint heat of distant worlds. Others were tuned to follow high-energy events that briefly flare and fade in distant galaxies. With each launch, the universe revealed another soft layer of its complexity. Infrared space telescopes learned how to see warmth itself. They observed the gentle glow of dust surrounding newborn stars, the hidden movements within thick molecular clouds, and the faint heat signatures of planets far beyond our solar system. Where visible light was blocked, infrared vision passed smoothly through, uncovering entire regions of space once thought invisible. These telescopes had to be kept incredibly cold, wrapped in reflective shields and cooled nearly to absolute stillness. They floated in darkness as silent listeners for faint thermal whispers. Even the slightest warmth from their own instruments could overwhelm the signals they sought, so they rested in careful balance between light and shadow. At the same time, gamma ray and X-ray observatories watched the most energetic events in the universe. When stars collapsed, when black holes fed on surrounding matter, when distant galaxies released sudden bursts of unfathomable power, these telescopes observed the universe at its most extreme. Yet, even these violent events arrived at Earth as quiet data streams, transformed into calm measurements and gentle graphs. Through these different eyes of space, scientists learned that the universe is not only vast, but constantly active. Stars are born in hidden cradles of dust. Others grow old and release their matter back into space. Galaxies collide and merge over spans of time so long that their motion appears frozen to human perception, yet nothing truly stands still. Space telescopes also reveal that our own solar system is only a small member of a far greater family. The discovery of planets orbiting distant stars transformed astronomy from a study of lights into a study of worlds. Some of these planets circle their stars so closely that their skies glow with permanent heat. Others drift so far away that their surfaces remain locked in icy shadow. A few move through regions where gentle warmth might allow oceans to exist beneath alien skies. These discoveries arrived softly, one after another. There was no sudden announcement that the universe had changed, only a quiet accumulation of knowledge, steadily reshaping how humanity understands its place among the stars. As engineers learned more about placing instruments beyond Earth, telescopes were sent farther from the planet itself. Some were guided to positions where the gravitational pull of Earth and the Sun balanced perfectly, allowing observatories to float with almost no fuel. From these stable regions, telescopes could observe the universe with steady focus, free from Earth's shadow and heat. From these distant vantage points, they studied the slow bending of light around massive objects, confirming the subtle warping of space itself. They measured how fast galaxies were moving away from one another, refining our understanding of cosmic expansion. They listened for faint ripples in space-time created by massive collisions far across the universe. All of these measurements arrived without sound. No explosion echoed through space. No alarm rang across the stars. Only streams of quiet data flowed back toward Earth, carried by invisible radio waves, interpreted slowly by patient minds. With each new observatory, humans refined not only their machines, but their questions. Early telescopes asked what planets were. Later ones asked how stars are born. Newer ones ask how galaxies form, how time itself stretches, how the universe began, and what its distant future might hold. The questions grew deeper as vision grew clearer. Yet, no matter how advanced these instruments became, they remained humble in one essential way. They could only receive what the universe chose to send. They could not command light to arrive. They could only wait for it. Light that left a distant galaxy millions of years ago might arrive tonight. Light from a star that no longer exists might still be drifting quietly toward a waiting mirror. To look through a space telescope is to look backward through time, not by force, but by patience. And so, space telescopes continue to teach the same gentle lesson again and again, that the universe reveals itself slowly to those willing to wait, to observe without urgency, and to listen without expectation. Let this quiet patience settle within you now. Let time feel wide. Let distance feel gentle. Nothing is rushed among the stars. As humanity's understanding deepened, space telescopes began to take on a new mission, not only to observe distant stars and galaxies, but to search for the faint signs of life beyond Earth. This search was never hurried. It unfolded slowly, one fragile possibility at a time. Telescopes learned how to study the thin atmospheres of faraway planets as they passed in front of their stars. A tiny fraction of starlight would slip through these distant skies, carrying subtle fingerprints of gases drifting within them. From these quiet traces, scientists could tell whether a world held water vapor, carbon dioxide, methane, or other molecules tied to the chemistry of life. These methods required extraordinary sensitivity. The change in light was often smaller than the width of a human hair seen from across a continent. Yet, with patient observation, repeated measurements, and steady refinement, these distant atmospheres began to reveal their secrets in whispers rather than declarations. Some planets showed skies thick with heat-trapping gases. Others glimmered with hints of clouds. A few revealed tantalizing chemistry that stirred careful curiosity. Never bold claims, never certainty, only the soft question of possibility. At the same time, space telescopes continued to observe the slow history of the universe itself. They traced how the first simple clouds of hydrogen gradually assembled into the first stars. They studied how those early stars enriched space with heavier elements through ancient stellar explosions. Over long ages, these materials became the building blocks of planets, oceans, mountains, and eventually living beings. In this way, space telescopes quietly showed that the matter within your own body was once forged in distant stars. Every atom of oxygen you breathe, every trace of iron in your blood, every grain of calcium in your bones carries a history that reaches back to ancient suns that lived and died long before Earth formed. This realization arrived not with fanfare, but with a kind of calm wonder. Humans did not feel suddenly small. They felt quietly connected, woven into a story far larger than any single world. The engineering behind these observatories continued to grow more refined. Mirrors were crafted from segments that folded like petals for launch, then slowly opened in the silence of space. Light shields unfurled layer by layer, blocking heat from the sun and earth. Instruments cooled peacefully until they could detect the faintest glow from the coldest corners of the universe. Each new telescope was not simply a replacement for the one before. It was a new voice added to an ever-expanding cosmic choir. Older observatories continued their steady work while new ones joined them, each tuned to different wavelengths, different energies, different depths of time. Together, they formed a continuous awareness of the universe, spanning from the nearest planets to the most distant galaxies, from the birth of stars to the slow drift of cosmic darkness. Even when some telescopes reached the ends of their operational lives, their stories did not end. They remained in orbit as silent sentinels, drifting slowly through space, having completed their duty of quiet observation. Long after their instruments fell silent, the knowledge they gathered continued to shape humanity's understanding for generations. Throughout all of this progress, one quality never changed. Space telescopes were built not for speed, but for endurance. They were designed to last through years of cold shadow and steady sunlight, through countless orbits and quiet adjustments, always holding their gaze steady against the endless drift of space. They taught humanity how to observe without impatience, how to wait without anxiety, how to accept that the deepest truths often arrive slowly. As light continues its ancient journeys across the universe, mirrors remain ready, sensors remain alert, and human curiosity remains calm but awake, listening for whatever the cosmos chooses to reveal next. Let your thoughts drift gently with that light now. Travel without effort. Observe without urgency. Rest within the vastness that never rushes. As decades of observation gently unfolded, space telescopes became something more than scientific tools. They became quiet witnesses to humanity's slow awakening to the true scale of the cosmos. With every deep image and delicate measurement, the universe revealed itself not as distant and cold, but as an interconnected and living whole. One of the most profound achievements of space telescopes was their ability to peer farther back in time than any instrument before them. By collecting the faintest and most ancient light, they began to show the earliest structures that formed after the universe first cooled enough for stars to ignite. Tiny, fragile galaxies, small compared to the grand spirals of today, appeared at the edge of detectability, their ancient glow drifting through time like embers from a long-forgotten fire. These earliest galaxies were not yet elegant spirals or calm ellipticals. They were turbulent, chaotic gatherings of gas and young stars, shaping themselves through gravity's slow instruction. Space telescopes revealed that the universe grew its beauty gradually, not in perfection at the beginning, but through patient evolution. Some observatories focused their gaze closer to home. They studied the icy worlds of the outer solar system, tracing frozen plains, hidden oceans beneath thick ice, and complex atmospheres shaped by distant sunlight. They observed the quiet motion of comets drifting in from deep space, their ancient ices releasing soft veils of gas as they approached the sunday. They revealed storms larger than planets on distant gas giants, winds moving faster than any on Earth, and delicate ring systems that shimmer with countless particles of ice and stone. Even familiar planets took on new mystery when observed from the stillness of space. These discoveries reminded humanity that our own solar system is not static. It is a living arrangement of motion, gravity, light, and time shaped gently across billions of years. As technology continued to advance, telescopes learned how to correct their own vision with extraordinary precision. Tiny adjustments, smaller than the width of a human hair, could sharpen a distant galaxy into clear focus. Adaptive systems compensated for heat, movement, and the slightest mechanical drift. In space, where silence seems absolute, even the smallest motion matters. With this precision came clarity never before imagined. Disks of dust around young stars revealed neat gaps where newborn planets were silently growing. Stellar surfaces displayed waves of plasma rising and falling like luminous oceans. Binary stars danced around each other in graceful gravitational embraces that would take centuries to complete. Space telescopes also helped humanity understand its fragile home. They observed Earth's atmosphere from above, tracing the slow movement of clouds, the shifting of oceans, the steady pulse of seasonal change. They measured how sunlight warms the planet, how ice reflects it back into space, how delicate the balance of climate truly is. In this way, by looking outward, humanity learned to understand inward. The same physical laws that guide distant galaxies also govern the breath of our oceans, the flow of wind through forests, and the quiet rhythm of night and day. The evolution of space telescopes was never marked by a single moment of completion. There was no final arrival. Only continuous refinement, mirrors growing larger, detectors growing more sensitive, missions lasting longer, questions growing deeper. Yet, with each improvement, the same quiet truth returned again and again. No matter how powerful the telescope becomes, the universe always contains more than we can presently see. Every answered question reveals new mysteries resting just beyond the edge of light. And this is not a failure. It is the invitation, an invitation to keep observing, to remain curious without urgency, to accept that not all understanding comes quickly. Space telescopes do not rush the universe to explain itself. They simply wait, and the universe, in its own time, responds. Let that waiting feel peaceful now. Let curiosity soften into calm awareness. Let the slow turning of galaxies mirror the slow rhythm of your own breath. As space telescopes continued their long vigil, humanity's sense of time began to stretch in quiet ways. These machines taught patience not through words, but through what they revealed. Light arriving today may have begun its journey before mountains formed on Earth, before oceans filled, before life itself learned to breathe. And yet, it arrives gently, without drama, the way all of the universe seems to move slowly, steadily, without urgency. New space observatories were guided into place not with haste, but with careful elegance. Some settled into wide loops around Earth. Others drifted far beyond the moon, suspended in balanced regions where gravity itself seems to pause. From these distant, quiet stations, telescopes could look deeper and longer than ever before. They observed galaxies growing not in isolation, but in communities. Streams of gas flowed between them like invisible rivers. Gravity guided their slow migrations. Over ages unimaginable to the human mind, galaxies approached, embraced, merged, and reshaped each other into new forms. What appeared to be chaos revealed itself as long choreography written across the fabric of space. Space telescopes also taught that darkness is not emptiness. Vast regions that once appeared empty now glimmer with faint radiation, soft dust clouds, and subtle motions. Even the coldest space carries energy, memory, and trace movement. The universe is never truly still. One of the gentlest revelations offered by space telescopes was the understanding of how ordinary starlight warms distant worlds. By watching the soft dimming of stars as planets passed before them, telescopes traced delicate shadows cast across immense distances. From these shadows, the size, orbit, and nature of distant worlds quietly emerged. Some of these planets were found circling calm, long-lived stars that burn gently for immense spans of time. Others orbited restless suns that flare and shimmer with changing energy. Each system revealed a different expression of the same universal laws, repeated endlessly with subtle variation. The instruments themselves became more refined in spirit as well as design. Mirrors no longer formed as single pieces, but as many segments working together in silent harmony. Light shields stretched wide like cosmic wings, guarding fragile sensors from the warmth of nearby stars. Cooling systems whispered softly, allowing detectors to sense even the cold glow of space itself. Yet for all their complexity, these telescopes remain devoted to one simple task: receiving light. They do not shape what they see. They do not choose what arrives. They only wait, open and still. From their steady watch arose some of the most intimate views of the universe ever known. Star nurseries revealed filaments of dust glowing faintly in nearby starlight. Planetary systems appeared as glowing disks with young planets carving graceful paths through drifting gas. The violent birth of neutron stars shone briefly in distant flashes, then faded back into silence. Space telescopes even observed the subtle trembling of space itself as massive objects collided far away. These faint ripples passed through Earth with no sensation, no sound, only a whisper in delicate instruments. And from that whisper, the story of ancient cosmic collisions quietly unfolded. Each discovery added not noise, but depth. Depth of understanding. Depth of connection. Depth of wonder. Through all of this, Earth continued to turn below. Clouds drifted across oceans. Night followed day. And above it all, orbiting quietly and unseen by most, space telescopes persisted in their endless listening. They asked no reward. They claimed no attention. They simply remained. And in remaining, They allowed humanity to see more clearly not only into space, but into the nature of time, change, and quiet patience itself. Let your thoughts continue to drift with them now. Let distance feel soft rather than vast. Let curiosity rest inside calm. The universe is still speaking, and the listening continues. As the quiet work of space telescopes continued, a subtle shift occurred in how humanity understood observation itself. No longer was seeing only about looking outward. Seeing became a way of listening, a form of deep attention that accepts silence as part of the message. With every refinement and sensitivity, telescopes began to notice fainter and softer things. They detected the slow breathing of stars as their brightness changed by tiny amounts over long stretches of time. They watched distant suns tremble with internal waves, allowing scientists to learn what lay hidden beneath glowing surfaces. Even stars, it seemed, had inner motions that followed rhythms as ancient as the universe. Some telescopes dedicated their entire existence to watching single regions of sky for years without interruption. They observed stars rise and fall in brightness, planets cycle through repeated orbits, and distant systems evolve in ways too slow for ordinary eyes to notice. Through this steady gaze, time itself became visible. Space telescopes also taught humanity about endings, not as violent conclusions, but as transformations. They observed red giant stars gently shedding their outer layers into space, forming glowing veils that drift outward like luminous memories. They watched white dwarf stars cool slowly across immense spans of time. They witnessed supernova explosions that briefly outshine entire galaxies, then fade into quiet remnants that seed space with the ingredients for future worlds. In every ending, there was also a beginning. The elements scattered by dying stars eventually gathered again, pulled by gravity into new clouds, new stars, and new planets. Space telescopes revealed that the universe does not discard what it creates. It transforms it. As knowledge deepened, telescopes were no longer seen only as instruments of discovery, but as bridges across time. Through them, the present touches the distant past. A photon captured today may have left its source long before human history began. The act of observing becomes an act of communion across ages. The evolution of space telescopes did not move in straight lines. Some missions lasted far beyond what was originally expected, continuing their quiet work long after their designers had imagined. Others ended sooner than hoped, yet even their brief observations carried insights that rippled forward through future research. Every telescope, no matter how long it lasted, became part of a shared legacy, a growing archive of light gathered from across the universe. This archive does not shout, it waits. It invites careful reading, patient interpretation, and thoughtful wonder. And still, new telescopes were envisioned. Larger mirrors, colder sensors, wider shields, instruments capable of detecting the faint warmth of newborn planets, the dim glow of the first galaxies, the quiet chemistry of distant atmospheres. With each new design came the same gentle intention to see a little farther, a little clearer, a little deeper into the story of existence. Yet for all the complexity of their construction, the heart of every space telescope remains simple. It is a quiet, open eye turned toward the dark. It waits without demand. It receives without judgment. And the universe, vast and unhurried, continues to offer its answers in the same quiet way through light. Let that thought drift slowly through your mind now. Light does not rush. Time does not hurry. Understanding does not force itself into being. It arrives when patience meets attention. Above the turning Earth, space telescopes continue their silent orbit. They watch stars rise and fade. They observe clouds of dust drifting through ancient stellar nurseries. They witness galaxies moving along paths shaped by gravity across unimaginable eras. And in their waiting, they reflect something gentle and familiar. The way breath comes and goes without effort. The way night follows day without command. The way sleep arrives when the body is finally ready to let go. Let your thoughts become as still as those orbiting mirrors now. Let attention soften. Let the universe continue its slow turning above you, seen and unseen. As the long story of space telescopes continues to unfold, there comes a quiet understanding that their true gift is not only the images they return, but the way they slowly reshape the rhythm of human thought. They stretch our sense of time until patience feels natural. They stretch our sense of distance until wonder feels gentle rather than overwhelming. Across decades of observation, space telescopes have taught that the universe is not built in moments. It is shaped through steady movement, through quiet repetition, through cycles of birth and transformation that unfold far beyond the scale of a single lifetime. Stars do not rush to ignite. Galaxies do not hurry to form. Even light, the fastest traveler known, arrives only after unimaginably long journeys. In the soft language of gathered light, space telescopes reveal that nothing meaningful in the cosmos is instant. All things deepen through time. They have shown us that the sky is not a fixed ceiling, but an open depth without edges. The stars above are not decorations of night, but distant suns moving through vast patterns. The dark spaces between them are not empty, but filled with quiet motion, faint heat, drifting dust, and invisible threads of gravity. With each observation, space telescopes dissolve the illusion of separation. The same physical laws that guide distant galaxies also shape the motion of moons, the warmth of sunlight on water, the slow rhythm of seasons on Earth. The universe is not distant from us. We are within it, shaped by it, and observing itself through the fragile awareness of human curiosity. Even the instruments themselves reflect this connection. Built from earthly materials, metals forged in ancient stars, shaped by human hands, launched by flame, they drift far from Earth, yet remain tied to it by invisible threads of communication. Every signal they send home crosses immense distances to arrive as calm streams of data slowly transformed into understanding. In this quiet exchange between Earth and sky, space telescopes have become storytellers of light. They do not speak in words. They speak in glow and shadow, in color and spectrum, in subtle shifts of brightness that reveal motion over time. Their language is slow. Their meaning unfolds gradually. They have shown us worlds wrapped in thick clouds, where rain may fall beneath alien skies. They have shown us stars arranged in vast spirals that rotate so slowly their motion feels eternal. They have shown us the faint relic glow from the earliest moments of the universe, still drifting through space like a memory that never fades. They have watched stars being born and stars reaching their final quiet states. They have traced how simple atoms become the building blocks of planets, oceans, and eventually living beings capable of looking back at the sky. In doing so, they gently remind us that the universe is not separate from life. It is the source from which life continuously arises. As the present generation of space telescopes continues its watch, new observatories are already being imagined. Instruments that will see even fainter light, telescopes that will study the soft chemistry of distant atmospheres with finer precision, observatories that may one day glimpse the first subtle signs of life stirring on other worlds. These future instruments are not designed for certainty. They are designed for listening, and the universe, vast and unhurried, will answer in the only way it ever has, through quiet light traveling across immeasurable time. Yet no matter how far technology advances, the essential posture of observation remains unchanged. A mirror opens, a sensor waits, light arrives, understanding grows slowly. There is no rush. There is no final revelation, only a continuous deepening of awareness. In this way, space telescopes mirror the inner journey of rest itself. Sleep does not arrive by force. It comes when the mind releases urgency, when attention softens, when breathing slows and effort fades into stillness. The universe does not reveal its secrets to those who demand them. It reveals itself to those who wait. And so, tonight, as your thoughts settle and the quiet continues around you, imagine those distant instruments still drifting silently above Earth. They move without sound. They turn with gentle precision. They watch stars rise and disappear beyond their fields of view. They collect ancient light without judgment or expectation. They do not hurry the cosmos. They do not disturb its rhythm. They simply remain present within it. And in that presence, something profound becomes clear. We are not separate from the vastness we observe. We are expressions of it, temporary patterns of awareness formed from ancient matter and starlight. The atoms within us have traveled through countless transformations, shaped by supernovas, by drifting gas clouds, by the long orbit of time itself. When you breathe, You are participating in the same cosmic exchange that shapes stars and planets. When you rest, you follow the same rhythm of release that governs night and day across the universe. Above oceans, forests, deserts, and cities now wrapped in darkness, space telescopes continue their gentle orbit. They watch without interrupting. They observe without attachment. They remind us that everything unfolds on its own quiet schedule. Nothing you seek needs to be rushed. Nothing you fear needs to be forced away. Understanding, like sleep, arrives when the moment is ready. Let your thoughts now drift as lightly as distant starlight. Let your breathing become as slow and steady as orbital motion. Let effort dissolve. Somewhere far above, mirrors remain open to the dark. Somewhere far beyond, stars continue their patient burning. And here, in this quiet moment between waking and sleeping, you are safely held within the same gentle universe that space telescopes have spent a lifetime learning to observe. There is nothing left to do, nothing left to analyze, nothing left to pursue. Only rest, only quiet, only the slow, endless turning of the stars.